And welcome to a new problem solving session. This session belongs to problems based on dipole, electric dipole, whose dipole moment is P. It is usually from negative charge to positive charge in physics. And you know the basics of dipole, and I'm going to solve problems based on it. This problem asks that you know that electric field produced by a dipole at a point R, the point is here, can be written in this form. It is usually not written in Indian textbooks, but this form is more useful than the usual forms we know. So I'm going to write down in this form. My job is to simply write the formula for electric field in this coordinate free form, and to do so I'm going to choose coordinates so that point P lies at the origin and points in the positive direction of x-axis, and the potential at this point, whose coordinates can be written as r theta, is phi r theta is equal to P dot unit vector r divided by 4 pi epsilon naught r square, and the angle between P and R is theta, so P dot unit vector r will simply become P cos theta. You can write like this. This will become P cos theta by 4 pi epsilon naught r square. And to get the field, that means electric field, we take the negative gradient of potential, because field is negative gradient of potential, and I'm going to find first the electric field in radial direction, that is also called the radial component of the dipole field. And since if you can break this dipole moment in the direction of vector r and perpendicular to it, this is basically your r component, radial component of dipole moment, and transverse component of dipole moment. But electric field here is, we know, you have solved the problem before. You have gone through the theories that the radial electric field in the direction of radial component of dipole moment, but its transverse components are opposite. So I'm going to find first the radial component of the electric field, and this is simply the negative gradient of potential, that is phi, and you know how to do this. You have to take theta as a constant and differentiate with respect to r, and your result is going to be 2p cos theta by 4 pi epsilon naught r cube. I have all these things memorized, so I'm getting no problem. And in the same manner, you can find the transverse component as minus 1 by r d phi by d theta, and you will get this result p sin theta divided by 4 pi epsilon naught r cube. And of course you can find also a component of E phi, that is in the increasing direction of phi in xy plane basically, and you will get this value. You will write in the place of 1 by r, you need to write down the length of this thing. Since this angle is theta, so this angle is theta, and this length is simply r sin theta. So you can write here 1 by r sin theta del phi by del pi. May I write potential as V, because this becomes something else, del del v by del phi. Phi is one of the coordinates, so I made a mistake here taking it phi. I should have taken it as another angle, because phi is reserved for potential in our case. So if I write again potential, v for potential, the result will be equal to 0, because v doesn't depend on phi in any manner. And the electric field, finally you can write in terms of r and theta as in vector form as p by 4 pi epsilon naught r cube, and its radial component has got 2 cos theta as a coefficient after taking p by 4 pi epsilon naught r cube as common, and you can write a unit vector r here, and plus, because it is in increasing direction of theta according to this coordinate system, you can write e theta, and after taking common p by 4 pi epsilon naught, we have only term left as sine theta, so you can write it as sine theta, theta, unit vector theta in the direction of transverse, and in transverse direction. And this is our electric field we obtained, but we need to write down in this result in this form. And how can we do this? Since we can write some things like vector p here is vector p can be written in general in terms of its radial and transverse components as p equal to radial component of p in radial direction plus transverse component of p in transverse direction, and p dot r is simply p dot unit vector r is simply p cos theta, and this p theta, this is p theta, and unit vector theta will be in this direction, so these are in opposite direction, but p dot theta is simply p sin theta, because you have to put in this direction, and this is this angle is theta, and this angle is 90 minus theta, so this p theta magnitude is p sin theta, and p dot theta is p sin theta, but the component, this component of dipole moment is opposite to the direction of unit vector theta, so we can write here as minus theta. So p can be written like something like that, like this. And now what? Now we have one thing in expression, that is this thing, and you know, let's take the whole expression. In fact, this is simply written as 1 upon 4 pi epsilon naught 3 p dot r vector by r5 minus p upon r cube. I guess this is, I have written it all correctly. Okay, so this thing is correct, the expression I wrote here is correct. And if we express these vectors in terms of a unit vector r simply, one thing you will agree in that 2 r's can be this. Simply we can write this thing as p dot unit vector r, then you can write here simply r5 r cube in place of r5, and this is p by r cube. So we can write something like 1 by 4 pi epsilon naught r cube, and the term in inside the bracket can be simply written as 3 p dot unit vector r minus vector p. Yeah. And now we can simplify this thing. 3 p dot unit vector r minus p vector, simply by writing p dot r is nothing but p cos theta and unit vector r minus p, and p we have earlier wrote like this. Okay, and we can put all the results, and it will become minus p cos theta r minus becomes plus p sin theta, and you can see here you get your result as 2p cos theta r cap plus p sin theta cap. And so this result and this result both are same. So this result can be also written in this form or in this form, because they are not different. There is a whole vector r and here are unit vector r. So both the results are same and you can write them as well. Thank you very much for watching.